Using a binary trie is a very good idea to go for the longest prefix matching in a very organized way. But could we further improve it? Using level compressed tries, we can reduce the traversal time. In this module, we shall understand what do we mean by traversal time and how can we achieve the level compression. Anurag Kumar suggests that the routing table entries can be organized in the form of binary tries. These binary tries take their own time complexity and we can reduce that. The traversal time in a binary tree is the same as the traversal time in binary tree as a graph. The complexity of depth first traversal is of the order of n plus m. That is n vertices and m edges. Because of the binary behavior, the complexity is generalized as n. Now, if you're looking for some kind of time reduction or speeding up, what we can do is we can compress this trie or we can compress the binary tree. How can we do that? Rather than we define a level for each bit in the binary trie, we define a level for a group of contiguous bits. It is tricky to make, but the traversal is going to be very fast. As a simple case, if we look at the level compression and we say that we are going to make contiguous groups of k bits in the case of IPv4 32-bit address, and if k is equal to 4, then we are looking for a tree that has the number of levels as 32 divided by 4, which is 8. Now, since we are deviating from the binary trie anyways, instead of two-way branching, we'll say that we'll have two k-way branch. That is, k refers to the number of contiguous bits. So 2 4-way branching in the case of the example that I gave for a 32-bit IP address, if we are making groups of contiguous 4 bits. Another way of looking at level compression is that a subtree of height k is compressed into one level. That's the same way of saying the same thing. The level compression essentially implies prefix expansion because we were looking at the prefix as a one bit comparison. Now we have slight deviation. For the same routing table that we saw earlier, the deviation is, now we have in this tree, let's look at the leftmost branch. We have 0 0 star 0 1 star. What does it mean? It means that we have grouped them at the same tree level, and both of these are represented by an entry A, whereas in the routing table it was represented as 0 star, which was an A. Let's look at another one. We can look at K. K was initially 0 0 1 0 1 star, but here we have expanded it as 0 0 1 0 1 0 star and 0 0 1 0 1 1 star. Now we have created two branches from one branch. The trie, or in other words, the retrieval traversal for 1 followed by 6 zeros would now be, interestingly, taking the path on the right side, and then it would go up to G. That is, earlier we had 1G, now we have 2Gs. And here we see on the bottom right of the tree we have 1 followed by 6 zeros and a star, and 1 followed by 6 zeros and 1 and a star. This means that here we have an option. So G is actually not one level but two levels.